So I got two more things to discuss concerning the voting systems, and then we're gonna, like I said, move on to something that's quite different. Still kind of about voting, but not really. The first we started talking about last time, and that is the random dictator method. The random dictator method is somewhat silly, it seems at least, somewhat ridiculous, but the idea, I will refresh your memory, is you have everybody vote, and then you choose a vote at random from all the votes cast, and then just whoever they put as the winner, that's the winner. So everybody votes. Then after the fact, one vote is chosen at random. And then their top choice becomes the winner. It's called the random dictator because that person, the one that ends up getting chosen, is acting like a dictator because their choice just makes the whole decision. But they were chosen at random, so it's not like there is an identifiable dictator before you do the election. It's only sort of after the fact that one of the votes counts and nobody else's votes count. All right? The random person is chosen and their top choice wins. What's the point of this? Actually, this does a great job in handling one of the classical objections to democracy in general. And this is actually something that the people who created the United States of America, they were seriously worried a lot about a concept that we don't talk so much about, but the whole point of the random dictator, or one great thing about it, is it defeats what they call the tyranny of the majority. If you read about the people who created the Constitution and why the U.S. Constitution is the way it is, a lot of it is based on this concept that that people were very worried about, and apparently this was one of the big objections, around the rest of the world when the United States began. Other nations said those guys are a bunch of idiots because you could never actually run a country as a democracy. They're just gonna go nuts and end up killing each other, which is kind of what happened in the Civil War. But we got better sort of eventually. But anyway, there were a lot of democracy skeptics at the time. And this was actually one of their biggest objections. And in my opinion, actually, this is a totally legitimate objection to the concept of democracy. It's called the tyranny of the majority. And the idea here is if, say, 51% of the people agree on something, then in a democracy, those people, they get their way. If slightly more than half the people agree about something, are they going to get their way about half of the time? No, actually, in a democracy, they get their way 100% of the time. And this is the objection to the whole concept of democracy, called the tyranny of the majority. If 51% of the people agree in a democracy, they get their way 100% of the time. That's why this is called the tyranny of the majority. Even if you have a very slight majority, in a democracy, a very slight majority can still get their way at all times. All right? And so, what the people who created the United States, they intentionally made our system somewhat complicated to try to prevent this from happening. And this is one of the reasons why we have the three branches of government. If you think about people voting, the votes for people in the United States are always divided up by states. So there's 100 different senators and several hundred representatives. There's one president, but the president is elected in a weird way by the Electoral College. And then there's the Supreme Court, which is not elected directly by people at all. So all of these different weird systems are, you could say that they are in some ways undemocratic because they are just complicating You might say, why don't we just vote every person votes for everything? The reason that we don't do it that way is because of this, the tyranny of the majority. It's meant to be avoided, which means you want a society, I mean, their concept was, we want it to generally be democratic, and most things more or less are decided by voting, but you don't actually decide everything purely by voting, because that causes this weird tyranny of the majority thing. All right, this, let me just say, this was a huge concern in sort of the early days of people trying to run nations by democracies. And other nations have different approaches to how you deal with this basic problem. This was a big concern in the old days. People don't really talk about this anymore. Although sometimes people mention this when they're talking about the Electoral College system. The Electoral College is fairly controversial these days. A lot of people would like us to just get rid of it entirely. And sometimes people will say, no, you cannot get rid of the Electoral College, and you can't just vote the president by popular vote, because you will get the tyranny of the majority in that case. Anyway, this used to be a big concern. What's the difference, though, if you do things using random dictatorship? Actually, this whole problem just evaporates entirely. That's because if you're choosing the winner at random, rather than actually counting up all the votes, but you choose the winner as a random vote in the random dictator, so using the random dictator, if 51% agree, then you choose the results at random from all the votes. They get their way 51% of the time, which is actually, in my opinion, isn't that kind of better than if you had actually counted up all the votes? If you count up all the votes, they get their way 100% of the time. But if you choose the winner at random, then they get their way about 51% of the time, which from a statistical point of view, this is dare I say, better than actually counting up all the votes. So statistically, this is great, right? I would say this is a great method to use in the real world, especially if you are making decisions over and over again. This is when a random dictator method actually works very, very well. This works great. I'm going to say, here's my little slogan about random dictator. This works great for repeated elections with individual low stakes. I imagine something like, I think I mentioned last time, like deciding with your friends where to go for dinner. If there's some kind of imbalance on what kind of dinners your friends like, if you vote on it every time, then just the more popular option will win every time, which is not really what you want if you're going to do this every day. It's better if the more popular option wins most of the time, but sometimes you get the less popular options too. And that's what would happen if you do the random dictator method. Repeated elections with individually low stakes. This is an ideal situation for the random dictator. I happen to notice, sometimes I play the old Mario Kart with my kids. Sometimes I play the old Mario Kart by myself. If you play the Mario Kart online, I don't know if you've ever done this, with other people, everybody gets to, before you do the race, you choose which track you want to do, and everybody gets to vote on it. But they do not vote. You don't count up the votes when they do this in the Mario Kart. Everybody votes, and then there's a little they spin the wheel, and one of the votes is chosen at random, and that's the one that wins. This is exactly that system, the random dictator method. Works great for repeated elections having low stakes individually. So I'm gonna, there's a question on the homework about this. I'm gonna ask you to think about an ideal situation to use the random dictator method. There are situations in which it works perfectly. Anybody got any thoughts about that? I would say a situation where it does not work so well is just like an election that you're only gonna do once with very important results. Probably you don't want to decide that. at random, like say electing the president, I would say. I mean, it doesn't only happen once, but it happens infrequently, and it's super important. I wouldn't like to decide that randomly, but otherwise it's great. All right, excellent. That was the first of the two things I wanted to say about these voting systems. I got one more, and then we will move on to something completely different. So one last system. This is called approval voting. Approval voting is something that is near and dear to my heart. I'll, if you don't mind, I have a little personal story about approval voting. It's very important to me. In approval voting, here's the idea. This is not so much a ranked election. Actually, when you're doing approval voting, you don't ask the people to rank their choices, but it's still more sophisticated than just asking them who's your favorite, which is, I mean, the way we do it in the United States is typically just who's your favorite, which is not very subtle. Approval voting is slightly more sophisticated. So on the ballot, you don't rank, but each voter indicates which candidates they approve of. That's why it's called approval voting. Each voter indicates which candidates they approve of. And that's it. So, for example, a typical ballot would look like, you know, A, B, C, D. And I, as a voter, I'm not going to rank them in order. Say these are my 4 options to choose from. I just get to say, who do I approve of and who do I not approve of? So a typical vote would be something like, I go here and here. This means I like B and D. That's what a vote looks like in this system. Yeah. Yeah, sorry. I scrolled what I wrote. All right. So on the ballot, you do not rank your choices. You just say which ones you approve of. That's what an approval vote looks like. And then how do you can vote for as many as you like. If you only approve of one of them, you can vote for just one of them. Or if you approve of all of them, you can vote for all of them if you really want to. Or you can vote for none of them if you don't like any of them. All right. This is how approval voting works. You just check as many as you like. Check as many as you like. All right. And then who wins? Well, you count up the votes in the same way as you would if people were just checking one option. You just count up how many total approvals each of the candidates get. So I will say the candidate with the most approvals wins. All right, that's how it works. So can we just do a typical example election? This is actually much simpler than the ranked methods that we've talked about in the past. You know, this is one of the topics on the big checklist. One of them is about approval voting. You should expect a question about approval voting is probably going to be really easy, just because it's very simple how it works. But a typical election would look like, you know, I'm going to draw like one of those charts. Usually it's like, you know, 4 people said A, B, C, 5 people said B, C, D, or whatever. But in approval, they're not ranking in order. They're just saying who I approve of. So it's more like an approval election looks something like this. I'm going to put A, B, C, D like this, and something like this. So this means 23 people, they checked off A and B. And then 37 people checked off A and D. 4 people said just C. 17 people said A and C. 21 people said B and D. Let's say 3 people said everybody. All right, this is how a typical approval election looks when you ask everybody to vote in this kind of a system. They are not putting things in order. They are just saying who they like. And then how do we determine the winner? You just add up how many checks each person got. Of course, you have to pay attention to the numbers at the top. So how many total approvals did A get? A was approved by these 23 people, and also these 37, and also these 17, and also these 3. So this is going to be 23 plus 37 plus 17 plus 3. That's 60, I believe that's 80. So this is how many approvals A got. That is 80 total people checked off the A on their ballot. And then what about the B? The B gets 23 and 21 and 3, right? You're sort of adding up all the numbers corresponding to where you see the check marks here. This is 47, right? And so on. Provided you know what you're doing, this is not difficult. How many approvals does C get? They got 4 and 17 and 3, that's 24. And D gets 37 and 21 and 3, that's 61, I believe. All right, and so A is the winner. This is how you do approval voting. All right. Any questions about that? I mean, mathematically speaking, it's pretty straightforward. Yeah.
But ties, there's going to be times where there's ties where people have the same votes.
Yes, you could get a tie. I mean, I didn't in these results. All these numbers are different, so there was no tie here. You might get a tie just like, I mean, it's just like in any other system. You could, in theory, get a tie. Even if you're using the plurality or the border or whatever. If you ask people to do this in real life, like on a very large scale, then it's statistically basically impossible to get an actual tie. But it is possible, in theory. So if there's a tie, you just say there's a tie. This is used in the real world, actually. When they elect the Pope, they use approval voting. I don't know if you've ever heard about. They apparently actually make up like official paper ballots to elect the Pope, and all of the cardinals vote, and they're like ballots made of gold or something. This is the way they do it, though. They have several options, and you can just check off as many as you like. You don't have to just vote for one guy. You can vote for several guys when voting for the Pope. This is how it works. I actually don't know of other sort of important real scenarios. I believe actually the Academy Awards, the Oscars, works something like this. They have people who vote on those, and I think. Without watching the movies?
That's notoriously not a requirement.
Yeah, right. Sometimes, yeah. I'm not trying to give my hot takes about the Oscars, but apparently they vote according to something like this, where you're allowed to, you don't just have to vote for one, you're allowed to vote for more than one if you want to. That's the idea, all right? Something about approval in general that I can say is approval, this tends to elect middle ground candidates, which is either a good thing or a bad thing, depending on if you're an extremist or not. This, more so than the plurality system, this tends to be favorable to people who are sort of middle ground candidates. And it's not so hard to see why. You can imagine if, say, you have 3 options, and on the sort of liberal conservative spectrum, maybe, let's say one of them is in the middle, and then you have one who's liberal and one who's conservative. You can imagine in this case, so the super liberals, maybe they only like A. The super conservatives, maybe they only like C. But a lot of the people might say, I'm like a little bit liberal. I'm kind of liberal. That means I like both A and B. And maybe some of the conservatives, they like both B and C. It means that the B here, if you use approval, the B is going to pick up a lot of votes from being in the middle. Whereas if you were using plurality, those people that, like, maybe I'm a little bit liberal or a little bit conservative, they're more likely to shoot for the A or the C. They will vote for the extremes because they might think the person in the middle doesn't have a chance of winning. But if you're using approval voting, it actually helps out the middle ground a lot, which, I mean, depending on your political philosophy, this might be a good thing or this might be a bad thing. Can I tell you my own personal story involving approval voting? This is a true story. The faculty of Fairfield University occasionally vote for things, and one thing that we vote on is who is on various faculty committees. We have committees about like deciding, approving new courses. If some professor wants to teach a new course, it has to get approved by the curriculum committee, and so on. There are many committees. There are committees that decide like which courses get the social justice credit in the core. Those kinds of things are all decided by committees. And the way that we elect committees is by approval voting. And the reason we use approval voting is because I personally convinced the university faculty to switch to approval voting. Because when I first came here, we used plurality, which I really hated. You would get a ballot with sometimes like 10 different options, and we would use the plurality system, which is terrible when you have that many options. Especially when you're voting for people who you don't really know very well. Like I'm voting for people in the English department or something like that. It's hard for me to make an informed decision. When you're using the plurality system, you are forced to choose only one person to vote for. But the approval is much gentler. You can vote for as many people as you like. And actually, this was one of the things that helped me get tenure as a professor here, is that I could. And actually, if your professors in other departments, they probably don't know me because I don't get around all that often. I'm not here to make friends, as they say on the reality TV. But if you're trying to convince, I don't know why you would ever do this, but if you're trying to get one of your other professors to know who I am, you could say, you know that approval voting guy? That's me. I'm that approval voting guy who changed the voting system. One of my great accomplishments at this great university, probably had minimal effect on anything in reality, but something that I can be proud of at least. All right, that is approval voting, near and dear to my heart. And I actually, if you ask me, I kind of like the ranked choice in the real world, but the ranked choice is fairly complicated. The approval voting, when it came to me convincing people to switch to approval voting, this is a much easier sell because it's much mathematically much simpler than the ranked choice or other things like that. Really, all you have to do to explain this to somebody is it's just like a normal election where you vote, but you don't just have to pick one choice. You can pick as many choices as you like. That's the only difference. And everybody, for the most part, kind of gets it. So approval voting is a great system to use if you don't mind electing middle ground candidates. I think actually for the committees at Fairfield University, this is probably a good thing. We do have sort of extremists among the faculty on university issues, and to me, it's better to keep the extremists off of the committees and let the middle ground people in there. All right, any thoughts about approval voting? This is all I wanted to say about that. All right, this ends the first part of the course then about ranked voting systems. On the big checklist of topics, those are all labeled with A. And this is the end. The last of those was approval voting. So turn a new page in your notebook if you like. I'm going to scroll down to the next page. It doesn't really matter. What we're going to talk about for the next couple weeks is still vaguely related to voting, but it's actually going to be very different in nature and a totally fresh start. This has nothing to do with the monotonicity or any of that kind of stuff. What I want to talk about for the next couple weeks is called weighted voting. So still vaguely about voting, but very different in terms of the kinds of stuff that we're going to be talking about. Weighted voting. So one thing that we have not really talked about at all, and I don't know if you really wanted to talk about it, is the Electoral College system in the United States is a weird thing that we do here only to elect the president. It's not used for any other purpose, but it's called the Electoral College system. The Electoral College system. You want to hear another personal story? This is in my opinion, a funny story. The Electoral College, every time we have a new presidential election, there's a bunch of people who are grumbling about the Electoral College. People think that we shouldn't use the Electoral College to elect the president. Mostly those people are Democrats because right now the Electoral College system favors the Republicans quite a lot. We've had, several of our recent presidents have been Republicans, even though if we had not used the Electoral College, if we just voted directly, then the Democrats would have won 7 out of the last 8 presidential elections. But George Bush and also Trump won because of the Electoral College, even though they got fewer votes overall. When I remember around the election, the 2016 election, I believe, between Trump and Clinton, I was at the grocery store at the ShopRite, and I saw, as I was checking out, an issue of Cosmopolitan magazine, and on the cover, it had like one of the little headlines on the cover. It said, "Learn to love the Electoral College system." And I thought, that's weird. What is Cosmo talking about the Electoral College system for? And being a socially confident man, I was not confident enough to pick up the Cosmo off the shelf and start reading it at the ShopRite. So I decided afterwards to look up. I figured I could get that article online because I want to know why Cosmo thinks I should love the Electoral College system. Because to be honest, personally, I don't really love the Electoral College system. I couldn't find it. I looked online, learn to love the Electoral College. I couldn't find it at all. It took me forever. I eventually found a picture of the cover. Like, I was going crazy. Like, I really saw this, didn't I? I found a picture of the cover, which had the headline, and I saw it didn't say electoral. It said erectoral. That way. Learn to love the Electoral College. All right. So this is not what I thought at all. Yep. And at that point, I stopped looking for the article. I never read the article. But check it out if you're interested.
Oh my God.
Anybody got back issues? Yeah. I don't
think that was an accident.
No, it's not an accident. No. I mean, this is what Cosmo is all about, isn't it? The Electoral College. I don't really know what that means, but I have a vague idea of what that means. Yeah. Anyway, the Electoral College system. Can we talk about the Electoral College system? This is the system whereby, if you're not familiar, each state in these grand United States gets a certain amount of points. And this is based on the populations of the states. So the big states get more points. The smaller states, big by population, and the smaller states by population get fewer points. And in order to become the president, actually it doesn't matter how many individual people vote for you. It is how many points you can accumulate by getting majorities in each of the states. And the points go like this. Each state gets a certain amount of points. This is not typically used when you're talking about the Electoral College, but in our setting, this whole section is called weighted voting. These points we're going to refer to as weights. So each state gets to participate in the election, and each state has its own weight. And the weights, I looked up these numbers here. So these are, California is the biggest state by population, and California gets 54 Electoral College votes. That means whoever wins the majority of the votes in the state of California, they get to count 54 votes towards the election in the Electoral College. The next biggest state is Texas, which gets 40. Actually, these numbers change every time the new census happens, and these are new numbers. Actually, I think the last presidential election we had, they were different, but I looked them up for this is what it's going to be in 2024. Then the next biggest one is Florida with 30. Then New York, the state of New York with 28. I will just say, etc. It goes down from there.
28 or 38?
28, yeah, sorry. Yes, it's 28. I'm trying to write them in order here. Thank you. And then the very smallest states, the lowest ones, are 3. For instance, Delaware is a 3 on this scale. 3 is the lowest you have. So this is all described specifically in the Constitution, and the rule is every state, the number of electoral college votes you get is equal to the total number of senators plus Congress representatives from that state. This is why the minimum is 3, because every state has 2 senators plus a certain number of representatives, and the smallest states have only 1 representative, and so they get a total of 3. And California apparently has 2 senators plus 52 Congress representatives, and that's why they get 54 votes. Anyway, these are the weights in the Electoral College system. And in order to become the president, so to be the president, you don't have to get the most votes overall. You need to get a majority of the weights, right? You need to get the most Electoral College points. And it is possible to get the most points even if more people voted for the other guy. This is what happened with Trump and Hillary Clinton. Trump won the Electoral College vote, even though more individuals voted for Hillary. And this also happened with the Bush versus Gore. Gore won more individual votes. That's called the popular vote, whereas Bush became the president because he won the Electoral College votes. All right. This is very controversial. Like I said, there are a lot of people who want to change this. Some people who want you to learn to love the Electoral College system. And like I said, generally speaking, these days, the Republicans love the Electoral College system and the Democrats hate it because it is making Republicans presidents win elections, and it is preventing Democrats from winning elections. I don't need to give you my hot take. There are organized efforts to get rid of this system, but it would take, basically, to get rid of the system, you have to, it would require a constitutional amendment, which requires supermajority of states to agree on. And right now, there's no way that...
That's like 37 states?
37? Yeah, I think it's 2/3 of 50, whatever that is.
It's whoever gets to
Is it?
2/3 first. It's not even necessarily like majority, it's whoever gets to 2/3 first. Well,
To pass a constitutional amendment?
no. Oh, I thought you meant for the Electoral College. To pass a constitutional amendment is different.
Yeah. But what I'm saying is to change the system and get rid of the Electoral College basically would require a constitutional amendment, which requires agreement by most of the states, which is not going to happen these days. Okay, anyway, this, though, is an example of a weighted voting system. This is a system in which the different voters count for different amounts, right? This is like in our class, I could say, hey, let's vote if we're going to have homework next week or not. But we can vote, but my vote counts for 30, and your votes individually count for 1. That's a weighted voting system where I just for whatever reason, some people's votes count more than some other people's votes. You guys doing all right?
Yeah.
All right, it's a little distracting. A weighted voting system, all right? It's when different people's votes count for different amounts. This actually happens a lot in the real world. I mean, one example is the Electoral College. If you imagine in the Electoral College system, it's almost like each individual state is operating as a single voter and their votes count for different amounts. This also is very common. Maybe this is basically the way that it's always done. This is used in corporate voting for public companies That is, companies, it's not only public companies, but companies in which different people own different portions of the company. Like one person owns 54% of the company and then some other people own less. In such a situation, when they vote on making decisions in the board of directors or whatever, they don't just vote one person, one vote. They vote where each people vote in proportion to their ownership in the company or their stake in the company. So this is like the standard way in which companies are run. And this is why, for instance, you can basically take over a company by buying enough stock. If you own 51% of the stock, then automatically you run the company because any votes that they have, your vote would count for 51% and whatever you say goes at that point. So weighted voting is super important. All right. Can I say some basic terminology, and then we'll talk about some examples. So basic terms. Each person, I'm going to say each voter has a weight. All right, that's just like how much your vote counts. In a traditional democracy, everybody has the same weight, but that's not what we're talking about. We're talking about systems in which different voters have a different weight. This is how much their vote counts. And as far as we're going to talk about in this class, we're going to focus on voting for yes/no choices. All right. So not voting between three alternatives A, B, C, but let's just imagine that there are only two alternatives, which this is typically how the Electoral College is. There's two political parties and they're just deciding the one or the other. All right. We're going to focus on voting just for two choices, which we're usually going to imagine that they are yes or no, although it could be two other things, paper or plastic or whatever, but we're going to focus on voting for yes and no choices. And there is, in any such system, there is always a quota. And this is the number that it takes for your team to win, all right? Every voter has a certain amount of weight, and those weights have to add up in order to reach the quota if you want to win. So there's always a quota. This is the total amount needed to win. All right. In the Electoral College system, anybody know how many electoral votes do you need to win in the Electoral College?
207?
It's I think it's 270. I believe is the quota for the Electoral College in the United States. But anyway, that's what the quota means. All right. So every different weighted voting system, it has a bunch of weights, and then it has the quota. That's pretty much all you need to know about the system in order to understand, mathematically what the system looks like. All right. The quota is the total amount needed to win. And I'm just going to say this is not always 50%. Usually when people vote for things in the real world, you have to get 50% in order to win the election or whatever. But that's not always the case. You probably know in politics, like in the rules of the Senate or whatever, there are some situations in which they say you need a 2/3 majority in order to win this vote, or you need a 3/4 to win this, or in some cases votes have to be unanimous in order to pass. So the quota here, I'm just emphasizing, is not always 50% of the weights. It is whatever it is in any situation. People decide the rules before they vote on it. All right. I would like to let's just look at an example. So here is an example with, let's say there are 5 voters, and the weights are 10. What? Sorry, I'm gonna write them in order, sort of biggest to smallest. 12, 10, 5, 1, and 1. All right. These, let's just imagine we have 5 people who are voting on something. These are their weights, and then I have to tell you what the quota is. Let's say the quota is 20. So you need to get to 20 in order to win in this scenario. All right. This is just a made-up example. But let's imagine that this is a scenario here. There's actually, you know, when we talk about examples in this section of the course, we're going to talk about many different examples that look exactly like this with just different numbers. Yeah, question?
This is pointing out the problem. Unless, if 12, if like the 12 weight votes different, but everyone else votes the same, nobody wins because that only adds up to 17.
Yes, that's right. Yes, that's right. Yeah, so it is possible in some situations that the quota is never reached.
Okay.
And that means if we imagine they're voting on like a yes or no decision, that means the no wins.
Okay.
So the quota is what you need to reach in order to get to the yes result.
Got it.
Yeah. There's a notation for this, like I was saying. Just since we're going to talk about examples just like this all the time, and it's a pain to write out all of these little words here, here's the notation. I'm always going to write it like this. You see one number and then a colon and then these numbers over here. All right? So when you see that, this is a description of the entire scenario that I'm talking about. This first number here is the quota. And then these numbers here are the weights. All right. This is the notation that we're always going to use here. And the standard problems that we're going to try to look at is, when you look at the numbers here, how can you tell who has the power in this scenario and who doesn't? Specifically, I want to know something like, this is like the big question that we are going to be talking about. The overall big question here is, in this system, who has the power? Obviously, different people have different amounts of power, but can we be more specific than just saying that? Like, for example, I can say obviously the 12 has more power than all the other people because that, 12 is bigger than 10 and 5 and 1 and 1. And if you believe the numbers, I suppose the 10 has slightly less power than the 12, and the 5 has a bit less than the 10, and then the 2 ones at the end have even more so less than the 5, right? This is the easy observation. But I would like to tell you, actually, not everything that I just said is true. In this system, who has the power? I'm going to say the answers are non-obvious. And this is, to me, what is interesting about the topic of weighted voting in general. You can look at those numbers, and it seems like, yeah, the 12 is more than the 10. The 10 is quite a lot more than the 5. The 5 is more than the 1s. And so their power, the 2 ones have the same amount, but the others have quite a bit more. Does anybody see why? Actually, that's not really true in this particular example. Anybody feel like... You have to keep in mind the quota. The quota is very important. In order to win the results, you've got to get up to 20. Anybody have any thoughts about that? Yeah.
Do the 12 and the 10 have like the same amount of power? Because if you have one and not the other, you can't reach.
Yeah, she said actually the 12 and the 10 have the same amount of power. That is true in this example. This is the interesting thing. Even though 12 is more than 10, you got to think about what are the various ways that we could get to 20. Actually, I think just look at how the numbers could combine with one another. I think the only way to get to the 20 is if the 12 and the 10 are both in on it, right? Because if you don't have the 10, if it was, say, the 12 and the 5 and the 1 and the 1, that only adds up to 19, all right? The only way you're going to make it to 20 is if you have the 12 and the 10 together. That means the 12 by itself doesn't have any power that's any different from the 10, right? So in this example, and this is the kind of thing that we're going to be looking at. This is not obvious just by looking at the numbers, but that's what's interesting about this. So in this example, I'm going to say to get to 20, we must use the 12 and the 10, all right? That's the only way you're going to make it to 20. And so in that sense, actually the 12 doesn't have any more power than the 10. They are of equal power in this system. Even though the number 12 is more than number 10, actually that is an illusion. It looks like the 1 is the more powerful, but it's actually not. So here, to get to 20, we must use the 12 and the 10. And so the 12 and the 10 here have equal power. All right? And what about the other ones? I'm going to try and keep it all on the screen here. The 5 and the 1 and the 1. Anybody have a comment about those? Yeah. Yeah, I would say in this case, they are completely irrelevant. Actually, if you think about all the different ways these numbers could add together to make it to 20, actually, there is no scenario in which the 5 and the 1 and the 1 make a difference. Because the only way you're going to get to 20 is if you have the 12 and the 10 together. That's already 22. Then the extra 5 or whatever, they don't make any difference at all. So here, 12 and 10 have equal power, and the 5, the 1, and the 1 all have no power. All right? So the moral of the story here is the weights themselves don't really indicate the different levels of power, right? Because, for example, here, the 5 and the 1 and the 1, it seems to me, just by the numbers, the 5 is much more than 1, which it is. But it doesn't matter. In this particular scenario, they're all equal. And the 12 and the 10 also are all equal, all right? This kind of a thing, in theory, may also be true of the Electoral College system, right? Like I wrote that list at the beginning. California has 54. Texas has 40. Is that what I said? Yeah. California has 54. Texas has 40. Does that mean actually California is more important than Texas in the Electoral College? The answer is, well, maybe it is, but actually it's not obvious, right? It's not automatic. Just because one of the numbers is bigger doesn't actually mean that one, the bigger one, is actually more powerful than the other one, right? This is what's interesting about weighted voting. So our big task for the next, week and a half or so, however long we're going to be talking about this, the big question is how can we measure the actual power, not just by looking at the numbers, because the numbers themselves don't actually tell you the whole story. How can we measure the actual power, right? And actually, we're going to talk about a few different ways to do it. And it's not like one way is right or wrong. There's just different ways of measuring power, just because power is a complicated concept in the real world. There is no one single mathematical way to measure differences of power. There are different ways you can think of measuring it that will give you different answers. But anyway, this is the big question that we're going to be looking at over the next couple of weeks. All right. We got plenty of time. Let's just look at another example. How about this? Another example. This is another one that's kind of extreme, just in the way that the power differences is interesting here. I have 4 voters. Their weights are 10, 10, 10, and 9. And in order to pass the law or whatever, you got to get to 30. Now, when you look at the numbers, it looks like we have 3 people that are equal, the 3 10s, plus 1 which is almost equal, but just like slightly less powerful. Actually, what I just said is not the case. Can someone give a more accurate description? Yeah.
Maybe we need all 3 10s, and so the 9 would be irrelevant.
Yeah, that's right. So the 3 10s together, they can make it to 30. Actually, the 9 cannot help out anything. The 9 doesn't have any influence at all in this case. So it would seem by looking at the numbers, the 9 is only like slightly less powerful. Actually, that's not the case. The 9 is completely irrelevant here. So the 9, it's just because of the structure of how these numbers relate to each other and what the quota is. So here, the 9 is irrelevant. Right? The other 3 have all the power, and the 9 has 0 power. All right? Okay, this is just a little preview here. Yeah, question.
So how is like quota determined for like each individual system? Like in relation to, is it like in relation to like, say if it's a company and like there's the big shareholder who owns like, say like 46% of
Yeah.
the stock. Like how is the quota determined by that or just it's set in advance?
Yeah, the quota is just sort of made up. Like when I made up this example, I made up those 4 numbers and I also made up the quota. It could be anything really. Although actually this is what I was about to talk about. But like in the real world, the quota is usually 50% of the total weight amounts,
Okay.
so that you have to get more than half of the people to agree. But you know, on certain types of decisions, they just say this time I want 2/3 or whatever. Yeah.
So just for practicality's sake,
Mm-hmm.
could this type of voting system or this type of structured system be exponential numbers, or do we actually cap it off at the number of weighted votes?
You mean like, oops, could it
Yeah,
could it have like many numbers
yeah,
here?
I mean, how would you even go about?
Yeah. In the real world, typically they would have many numbers. Well, like the example of the Electoral College has 50 different weights over here and 1 number. I suppose that's not a huge amount, but a big, you know, if you imagine, say, a big corporation like Apple or something, when they have a vote, actually, true story, I own some amount of Apple stock. That means in theory, every time they vote for anything at Apple, they should be asking me my opinion because I have a very small weight in that voting system. In reality, they don't even ask me. I guess my weight is just not enough. But there are thousands of people who have a small stake, maybe more than that. So yeah, a real world voting system like this has many weights on it sometimes. And the mathematics of analyzing that is really very difficult. For our purposes in this class, we're only going to look at, you know, ones that are this big or so, just because the math gets more complicated. All right. So this is kind of related to what she was asking me about, like what determines what the quota is. The answer is nothing really determines the quota. That number 30 was not calculated using the other numbers. It's just part of how the system is set up. But there are some restrictions on what the quota can be. Like there are some amounts for the quota which wouldn't make any sense. That's what I mean by restrictions, mathematical restrictions on the quota. For example, here is one which, I mean, you can write it down, but really this value of the quota doesn't make any sense in that system here. Anybody want to say, like in the real world, why is this kind of nonsensical? You would never want that kind of system. Yeah.
Can't reach it.
Yeah, because the quota is too big, it cannot possibly be reached here. So you would never actually want to run a vote using a quota that's that big, right? So the problem with this one is the quota is too big here, right? If you think about it, the biggest possible realistic value for the quota in this case would be 3. Like that, in theory, that would make sense. This would be a scenario in which you would require all of the voters to agree in order to pass it, which that's pretty extreme, but at least like mathematically it's possible to do that. In this case, the quota is too big. Specifically what I mean by too big is it's bigger than the total sum of the weights, right? Weights. The weights. Bigger than the total sum of the weights. That's why this is a problem here. The total sum of the weights here would be 3. That would be the biggest quota that makes any sense to use here. So one way that you could write this as a requirement for weighted voting systems, we always require, if I were to write the quota, I'm going to write this as a somewhat fancy looking equation here. The quota has to be less than or equal to this is what I'm going to write over here as the sum of the weights. That inequality thing there means that the thing on the left is smaller, right? Or equal. So the quota has to be less than or equal to the total sum of the weights. Otherwise, you would never get to the quota, and there's no point in voting in that sense. All right. So this is one requirement for what the quota is. Basically, you can make the quota whatever you want, but you have to abide by this, or else it doesn't make any sense in reality. All right. Yeah.
So why is the bonus on the quota and not on the weights?
No, you could say, from just the way that I'm talking about it, I would say what's wrong with that is the quota is too big. But another way you could say it is the weights are too small. Yeah, you could
change either.
you could leave the quota like it is and increase the weights. I suppose you could go up to, if you raise them all to 6, that's still not enough, but if you went up to 7, then that would be enough in this case. Although I'm just going to talk about in terms of the quota. All right. Is it possible the quota can be too small? Actually, that is also possible. For example, if the quota is too small, something like this. This is also unrealistic. All right. This is also unrealistic. Also not allowed. You might say, why, there's no problem with this. It just means that it's really easy to make it to the quota. But the problem with this is, for example, you can make it to the quota if only, let's say, only the 4 is in favor, but all of the others are opposed. That means the weight of 4 is in favor, but a weight of 11 is opposed. This doesn't make a lot of sense to actually make a decision when most of the votes are against it, right? That's what's wrong with this. So this is also not allowed because in this case you can meet the quota even with majority opposed, and this usually doesn't make sense to do things in this way. All right. You don't want it to be possible to meet the quota even if a majority of the voters are opposed to it. I don't mean a majority of the voters. I mean a majority of the total weights are opposed. All right. So this also is not allowed. The requirement for this, see, the problem here is that the quota was too small. I meant to write that at the beginning. All right. What is the way of writing this in terms of an inequality? We're going to require that the quota has to be greater or equal to 1/2 of the weights, the sum of the weights. And actually, sorry, I mean greater, straight up greater. Not, this is a technicality, but this is to prevent. You don't want to meet the quota if a majority are opposed. That's why I'm using 1/2 of the total sum to figure out what the majority is. And the quota has to be more than a majority of the total weights. That's what this says here. All right. You can kind of put this together with what I said up there. So up, you can see them both at once. Up here, the quota has to be less than that, but at the same time, it has to be more than that. This is a standard way that we like to combine that stuff together. So this, all together, I'm going to write this as like a double inequality with the Q in the middle. The Q has to be less than the total sum of the weights, and it has to be more than, I'll start over here, 1/2 of the sum of the weights. And it has to be less than the total sum. All right. This is the rule about what the quota is allowed to be. As long as it's it has to be. So technically, this is a less or equal. This is a straight up less than, not or equal. That's a little technicality that I don't care all that much about, but I might as well do it right when I write it. All right. These are the rules which say what the quota is allowed to be. It has to be in this range, or else it's not a realistic situation you're talking about.
Could
Yeah.
you go up like a little bit again? Sorry, I didn't.
Yes. Sorry.
Thank you.
I gotta slow my roll. All right. These are the rules about what the quota can be. Otherwise, as long as it's in between those two numbers, whatever they are, the quota can be whatever you like. All right. We got about 10 minutes left. I think we can start talking about some very basic measures of power in one of these voting systems. And then we will get to some more sophisticated things next time. So, basic measures of power. There are some situations in which it's fairly clear what the various power relationships are. Some kind of cut and dry situations in which you can say very cleanly. More ambiguous situations we're going to talk about later. But for the cut and dry ones, how about this? Here is an example that I have made up. How about that? 10 is the quota. 12, 4, 2, and 2. There's something interesting about this one, and that is that the first weight there, the 12, is actually more than the quota, right? 12 is more than 10. That is allowed. Here, the 12 meets the quota all by themselves. And everybody else together cannot make up the quota, right? Everybody else only adds up to 8 here. So in this case, 12 meets the quota all by themselves. All right. What that means is the 12 in this system has all the power. And this is just easy. This is always easy to identify. If you see one of your weights is more than the quota already, that means that this person on their own can decide whether the vote passes or not, right? And there is a word for that. We say the 12 is anybody want to guess? This is a word that we've used already in other contexts. This would be one voter who is able to make the whole decision on their own.
Dictator.
A dictator, yeah. We say the 12 is a dictator. Right? So, a dictator in weighted voting is very easy to identify. This is easy to spot. It just means the weight meets or exceeds the quota. By itself, right? It doesn't have to be greater. It can be a tie, and that's still okay. All right. That is called a dictator. And when there is a dictator, that means they have all the power and nobody else has any power. All right. This is always easy to tell. That's kind of an extreme case, very simple case to identify. What about the other extreme? That would be a voter who has no power at all. This is often harder to identify, but that's the other side. So the dictator is one extreme. There's the other extreme is a voter with no power at all is called a... So this would be something like, you know, this example from before. All right. It's not obvious, but it turns out in this example, the 9 has no power at all. The other 3 do. The other 3 are not dictators because, like this first 10 here, for example, cannot just make the decision all on their own. They can't make it to 30. They need the others to agree. But the 9, there is no scenario in which the 9 makes any difference at all here. And this is the other word. So the word for this, a voter with no power at all, I'm not making this up. This is really what it's called. This is called a dummy. All right. So in this example, the 9, so here, the 9 is a dummy. And there's no dictator. Right? A dictator means one of the voters is already exceeding the quota all by themselves. All right? How about, here's another example. How about 10, 5, 4, 1, 1. Is there a dictator? Is there a dummy? This is like a typical, fairly easy homework question. In this system here, is there a dictator? Dumb? Is there a dictator? Is there a dummy? What do you think, first of all, about dictator? This is very easy to decide. Someone, you want to show me the thumbs? The thumb shall be down. A dictator is somebody who already meets the quota all by themselves. And you can just tell none of those numbers is 10 or more. So none of them is a dictator. No, that's easy. The dummy, you have to look a little bit more carefully. So I would suggest you just think about the ones here. And you ask yourself, I mean, the ones, if anybody, they have the least power in this system. Do they have any influence at all? Is it actually possible for this one to make some difference? Could it possibly participate in adding up to the 10, or do they make no difference at all? Yeah?
I mean, they can. I mean, along with the 5 and the 4, they need a 1 to get to 9, so I would argue that there's no dummy vote.
That's right. So there is no dummy here. That's because I will say even the 1 can make a difference. For example, you could go something like 5 plus 4 plus 1 to make it to the quota, right? If you take a 5 and a 4 and then one of the ones, that makes it to 10, and that really made a difference, right? If you left out this one, then it wouldn't make it to 10 anymore. So even the 1 in that case can make a difference, so that means there is no dummy in that system. All right? Any thoughts about that one? All right, there's one more. We got 5 minutes. One more fairly simple, although slightly more complicated, type of power measurement that we can make in one of these systems. And that is, like in this one, for example, here I would say the 5, there's actually something special about the 5 and the 4 here. The 5 and the 4 are not dictators because it's not like the 5 all by itself makes it to 10. So the 5 and the 4 are not dictators, but I will have you notice that in order to get to 10, you must include the 5, right? Because if you don't include the 5, everybody else will be 4 and 1 and 1, that's only 6. So in order to make it to 10, you have to use the 5. And actually the same is true of the 4. In order to make it to 10, you must use the 4 because everybody else is only 5 and 1 and 1 is 7. So the 5 and the 4 are not dictators, but they are necessary in order to reach the quota. All right? They cannot make it to 10 all on their own individually, but the 5 and the 4 are required if you want to get to 10. All right? There's a word for that. So this is a word that actually is used in common, parlance. This is a word which indicates somebody, perhaps they cannot force the answer to be yes, it passes. But if they want to, they could sit out and it's an automatic no, right? The 5 and the 4 here, if they don't vote yes, it's an automatic no. So for them, they cannot make it a yes, but they can make it a no by saying no, all right? The word, anybody know a common word for that? This is used in politics.
Veto?
Yeah, this is called veto power. It means these people, the 5 and the 4 in this example, they cannot automatically make the result be a yes, but they can, if they want to, automatically make the result be a no by voting no. All right, so the 5 and the 4 are not dictators. They are necessary in order to reach the quota. We say they have veto power. They are not capable of making the result a yes, but they are capable of making the result a no. All right, that's called veto power. Okay, so in this example here, a typical homework question that I would ask is there a dictator? Is there a dummy? Is there anybody with veto power? So just to finish it off, the answer in this case is the 5 and the 4 both have veto power. All right. What about the 1s? Does this 1 here have veto power? Do you need this 1 in order to make it to 10? The answer is no, because you could add together the other ones and make it to 10. This may be a little confusing. Actually, you do need to use at least one of the 1s in order to make it to 10. But as an individual, you don't have to use this one to get to 10. And also, as an individual, you don't have to use this one to get to 10. So they do not count as having veto power. All right, and I think I will leave it at that. Next time we'll do much more examples like this.